Hey guys, let's talk about graphing quadratics in vertex form. So, the problem I have here is we're going to graph the following quadratic, which is in vertex form, and identify all the pieces of the graph. So we're going to be talking vertex, axis, symmetry, minimums, maximums, x and y intercepts, and domain and range. So to start off, let's just even talk about vertex form, which is y equals a x minus h squared plus k. Now, the reason it is called vertex form is when you look at the equation, it actually is going to give you the vertex. How this is all connected is it has to do with the transformations here. So the fact that we knew transformations from the previous chapter is going to help us here. So when I look at my equation, f of x equals x minus 3 squared plus 5, this x minus 3, or the minus 3 on the inside, is going to shift everything to the right 3, and the plus 5 is going to shift everything up. So we're going to shift right 3 and up 5. So if we go right 3, up 5, this is going to be our vertex. Okay. We could find out a lot more other useful bits of information here, but in our Algebra 2 class, we are allowed to use a graphing calculator, so we're going to use it here. So when I have this equation, f of x equals x minus 3 squared plus 5, we're going to graph it to get additional points here, and then we'll go through each of the pieces. So when I go into y equals, I'm going to type in my x minus 3 squared, x minus 3 squared plus 5. I can hit graph, which is great. I want to transfer this picture onto my paper. So already I've started graphing in the upper right-hand corner. This graph is also graphing in the upper right-hand corner. To get a few more points here, we're going to go to second table, and this is going to have a list of values in here that we're going to use. Now, my specific graph paper goes from 10 to negative 10, 10 to negative 10. So you saw me scroll up and down there. I'm looking only for the single digits here. So single digits between 10 and negative 10. So I'm going to plot all these points. So for example, I see a 1 and then a 9. So that is the point over 1, up 9. I see 2, 6. So I'm going to go to the right 2, up 6. 3, 5. Already had plotted. 4, 6. Right next to it. 5, 9. Right here. Only thing left to do is to trace on through and find that parabola there. There we go. So this is my graph. Okay, that's the easy part. What's tough is being able to identify all the important features here, from the vertex, axis symmetry, minimums, maximums, x, y, intercepts, domain, and range. So the vertex we kind of already talked about. Since this is vertex form, you're able to either look at the equation. Remember, h is always the opposite, k is just fine. So flip the negative 3 to a positive 3, and the k in the back. So 3, 5 is my vertex. You could find that by looking at the equation. You could look at your graph and find that point 3, 5. Or you could look in your graph. So the table here, see how points are kind of similar here. It's symmetric here. 14, 14, 9, 9, 6, 6, and right in the middle is 3, 5. Okay, so multiple ways you could go about finding that vertex. The next piece we're going to look for is something called the axis of symmetry. Now, axis symmetry, another name for that is the line of symmetry. If you look at my graph, and I'm going to use a red pen here to draw in what would be my line of symmetry. So using kind of a geometric idea there, what we have is this graph is symmetric with this red line down the middle. So down the left and the right, that is perfectly split in half, so it's symmetric. It's the same on the left and the right there. What we're looking for in the axis of symmetry is we're looking for the equation of this vertical line. So since it's a vertical line, it's going to start with x equals. Now here's what's the cool connection here is you notice our vertex was this point right here. This point and the axis symmetry are crisscrossing each other. So the vertex and the axis symmetry are in the exact same spot. So you're going to see things from the vertex and the axis symmetry that connect here. So if I'm trying to find the equation of this vertical red line, the equation of this is going to be x equals 1, 2, 3. Now what the cool feature here is if you notice, this is an x value here, x equals 3. If you look at the x value of your vertex, it is also 3. So these numbers match up. That is always going to happen. So if you know the x part of the vertex, you know the axis of symmetry. If you know the axis of symmetry, you know the x part of the vertex. These numbers will always be the same. And it goes back to the idea that the axis of symmetry is going to cross through our vertex. The next thing we're going to talk about is minimums and maximums. So when we graph quadratics in parabolas here, you're either going to have a parabola that opens up or a parabola that is opening downwards. When we're talking about minimums and maximums, we're talking about either the highest, if it's a maximum, the highest point we can go, or minimum is the lowest point we can go. So when you're looking at graphs like this, with the arrows, that means it's going to go on forever and ever and ever. There is no highest point because no matter what, there's always something higher. But on these graphs, there is a lowest point. So this would have a minimum. Where if you have a graph that opens downwards, you could talk about a lowest point, but there's always a point that's going to be lower because it continues on forever and ever. But the highest point, there is a highest peak, therefore it is a maximum. So what we're looking for is there a lowest point or is there a highest point? Minimum for lowest, maximum for highest. So if I look at my graph, yes, I have arrows on the end here. That means these graphs are going to continue on forever. So there is no maximum because there's always a point that's going to be higher. But a minimum, a low point. There is a minimum, there is a lowest point, which is right here. Now when we're talking about mins and maximums, we're talking about kind of a vertical movement here. High points, low points. So when we talk about mins and maximums, we're going to talk about them in reference to y, because y is something that moves us up and down. So I want to know the y value of this minimum point, because it is the lowest we can go. The y value here is 5. So here's the cool connection here. Notice this minimum point also happens at the vertex. So the vertex and the minimum, and it could be a maximum as well, are going to go hand in hand. If you notice, this is y equals 5, and the y value of my vertex is 5. That is also going to happen. So the vertex, the x part, is going to give you the axis symmetry. Those numbers will be the same. Minimums and maximums are talking about low and high points. That's going to deal with y, and it's going to be the y value of your vertex. So we know it's at y equals 5. So really interesting how things are kind of interconnected there. Our next few things are things we've talked about before, so I'm going to go a little bit quicker through there. X-intercepts, you're just looking for where does your parabola or quadratic cross the x-axis. In this specific example, I do not cross anywhere. It could cross in 2 points, it could cross in 1 point, or in this case, no points. So for x-intercepts, I'm going to go with none. Y-intercepts, few different ways you could go about doing this. One, you could look and see if there's a y-intercept, and for my graph, I don't see it, but if you notice, this part of the parabola is going up and to the left. So I'm going to assume there is going to be a y-intercept somewhere, I just don't know where. So I can't see it graphically. If I could see it graphically, I would write it down. Since I can't see it graphically, there's 2 ways on calculating it. One way is we know no matter where you're at on the y-axis, you're always going to have an x value of 0. So if I know x is 0, I could figure out y. How we're going to do that is we're going to take this x value of 0 and plug it in and simplify here. So what this would look like is 0 minus 3 squared plus 5, which you can rely a little bit on a calculator, or if you could do this in your head, 0 minus 3 is negative 3. Negative 3 squared is 9. 9 plus 5 gets you 14. So this y-intercept is at 0, 14. A little bit easier way to see that is the calculator. The table part of the calculator can help you there too. You know x is going to be 0. Well, it will tell you what's happening with y. When x is 0, y is 14, which is exactly what we got. So you can look at it graphically, you could calculate it by plugging and chugging, or just use the calculator. Finally, we have domain and range. That is not going away. Domain has to do with x values, range has to do with y values. So with the domain, we're talking about the leftmost point versus the rightmost point. The leftmost point is, even though this graph is going up, it is continuing to go to the left, to the left, to the left. So the lowest to the left we can go is actually going to be negative infinity. As we go to the right, this graph is continuing up and to the right, up and to the right. So we keep on going right, 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 which is going to be positive infinity. So that's my domain. With range, we're talking about y values. So now we're talking about lowest point versus highest point. The lowest point I could possibly go is right here, which is when y is 5. And since that is a point and not infinity, I'm going to use a bracket. The highest point we can go, well, no matter what, we're going up. And since it's in the positive direction, we're talking positive infinity. And since it's infinity, I'm going to use a parentheses. So that was a quick rundown on graphing any quadratic that is in vertex form.